Asteroid 16 Psyche contains more platinum than humanity has mined in all of recorded history combined. The global market for platinum fits inside a single mid-size warehouse. Every kilogram up there is worth roughly $30,000 down here. The mission would cost over $10 billion just to launch. The mission succeeds perfectly, and that is exactly what makes it a guaranteed financial loss. That number, $30,000, does not describe the platinum. It describes the gap between how much platinum exists and how little of it you can get. The moment a return mission begins loading its cargo hold, it starts closing that gap. Not gradually, not manageably. It closes it the way a dam breaks, all at once with no mechanism to reverse the flow. The engineering team celebrates on launch day. The finance team starts doing math it will not like. There's a version of this story where the logic seems obvious in the beginning. Rare material, high price, enormous quantity, simple arithmetic. Multiply the mass of the return cargo by the spot price, subtract the mission cost, and the number you get is so large it looks like a business plan. Every article that calls an asteroid a trillion-dollar opportunity runs exactly that calculation. None of them run the second one. The second calculation asks what happens to spot price when you introduce a supply the market cannot absorb. Earth currently uses around 200 tons of platinum per year. That is the entire global appetite. Fuel cells, catalytic converters, chemical manufacturing, the full industrial demand of a civilization of 8 billion people. A single mission returning material at the scale required to justify the launch cost would need to deliver thousands of times that annual demand just to approach a viable revenue number. That is not a delivery, that is a flood. Aluminum was once more valuable than gold. Napoleon served honored guests from aluminum plates, while lesser visitors used gold and silver. That changed the moment an industrial extraction process made large-scale production possible. Within 20 years, the price per kilogram dropped from the equivalent of a skilled worker's annual wage to nearly nothing. The material did not change, the scarcity did. And once scarcity leaves a commodity market, it does not come back on its own. Platinum is not different. It is more expensive than aluminum for exactly one reason. Earth cannot easily produce large quantities of it. Remove that constraint, and you are not entering the platinum market, you are ending it. The CFO watching the spot price update in real time as the cargo ship descends is not watching a number that will recover. The price does not pause. It does not stabilize at a lower level while the market adjusts. Supply shocks of this scale produce pricing that is structural and permanent because every buyer on the planet immediately recalculates their forward contracts based on what is now available. A car manufacturer looking at fuel cell production costs does not pay $30,000 per kilogram when the answer to how much is available has suddenly changed from barely enough to more than we can use in a century. They wait, they renegotiate, they pay a fraction. The mission's revenue model was built on a price that died before the cargo hatch opened. The obvious fix is to release the material slowly, sell gradually, drip the platinum into the market over decades, maintaining artificial scarcity by sitting on the inventory. The logic sounds reasonable. It does not survive contact with the interest clock. The mission's debt starts accumulating the day the rocket ignites, not the day the last kilogram sells. A $10 billion mission that takes 4 years in transit and then plans to release inventory over 30 years is carrying 34 years of compounding interest on a debt that must be serviced continuously. The revenue from slow drip sales cannot cover that service rate unless the price holds, but the market knows the inventory exists. Futures traders do not wait for physical delivery. The moment the cargo manifest is public, every forward contract in the platinum market reprices downward to reflect available supply. You cannot hide what you brought back. The drip strategy does not protect the price. It only delays the acknowledgement of the loss. There is a real entry in the historical record that shows what this mechanism looks like at scale. Between roughly 1545 and 1600, Spanish ships returned from Potosi in the South American highlands carrying silver extracted from what was then the largest silver deposit ever found. The mines at Potosi were operated under brutal forced labor conditions and produced quantities of silver that had no precedent in European history. The Spanish crown treated the inflow as pure gain. The logic was identical to the asteroid mining calculation. Enormous quantity of a precious material brought to a market that values it highly. The math seemed settled. What followed was a century of economic damage that historians still refer to as the price revolution. Silver flooded the European money supply. Prices across the continent doubled, then tripled over several generations. The purchasing power of wages collapsed. Trade networks built on stable commodity pricing destabilized. Creditors who had lent in silver found their repayments worth a fraction of the original loan. The Spanish economy, which had received more silver than any other, absorbed more inflation than any other, and by the end of the 16th century, the crown was effectively bankrupt despite sitting on the largest metal reserves in the world. The wealth was real. The market's ability to absorb it without destroying the pricing structure it depended on was not. No one planned that outcome. Every individual shipment made local sense. Bring back more silver. The treasury grows. The math worked for one ship. It stopped working when the total supply crossed the threshold the market could hold. The asteroid mission faces a compressed version of that sequence. The Spanish price collapse unfolded across generations. A single cargo return with meaningful mass could produce the equivalent structural repricing in a matter of months, because modern commodity markets operate at the speed of electronic trading and global visibility. The price revolution took 100 years. The platinum market version would take a quarterly earnings cycle. The mission also does not fail in isolation. Once the cargo is delivered and the price collapses, the companies and governments that currently operate platinum mines on Earth face an immediate revenue crisis. Those mines employ hundreds of thousands of people across South Africa, Russia, and Zimbabwe, which together produce over 90% of global supply. A price floor that drops towards zero does not just damage those operations, it eliminates them. The political response to an asteroid mission that wipes out the income of entire national resource sectors is not applause. It is litigation, trade restriction, and the kind of international legal challenge that does not get resolved on a favorable timeline for investors waiting to recoup a $10 billion launch cost. The mission's financial failure generates a second failure that makes the first one permanent. Every engineer who made the mission more efficient made this problem worse. A faster return vehicle shortens transit time, which means the market has less time to prepare for the supply shock. Better extraction hardware means more mass in the cargo hold, which means the price drop is steeper. Lower mission cost lowers the barrier for the next mission, which means competitors plan their own flights the moment the first one lands, accelerating the timeline to full market saturation. The incentive structure rewards the behaviors that destroy the return on investment fastest. Technical excellence and financial ruin are the same event viewed from different departments. The only economically rational use of asteroid resources does not involve bringing them to Earth at all. Materials extracted in space and used in space for orbital construction, in-space manufacturing, propellant depots never touch terrestrial commodity markets. Their value is set by what it would otherwise cost to launch that mass from Earth's surface. At current launch costs, that number stays high indefinitely. An iron beam fabricated from asteroid material in orbit and used to build a structure there does not compete with iron mining in Brazil. It replaces a launch manifest. That is a real economic argument, and it is the only one that contains its own negation. Helium-3 is the other candidate, an isotope rare on Earth but potentially abundant on certain asteroid and lunar surfaces, theoretically useful as a fuel for a type of fusion reactor that does not yet exist commercially. The economic case for extracting it depends entirely on a fusion industry existing before the extraction begins. Bring it back to a market that is not ready to buy it, and you have an expensive material with no buyers. Bring it back after the market exists, and you have a viable supply chain. The sequencing matters more than the extraction. The broader principle is not specific to Platinum or Psyche or any particular mission architecture. Value is not a property of matter, It is a relationship between how much of something exists and how much of it can be used. Disrupting supply does not increase that relationship's output, it collapses it. No amount of engineering changes this, because the engineering is not the constraint. The constraint is arithmetic. NASA's Psyche mission, which reached the asteroid in 2023, is not a mining mission, it is a scientific survey. But the data it returns will be used to argue the economic case for future extraction. The proposals are already in the literature, and the investment pitches exist. The next generation of mission planners will do the same calculation the Spanish crown did: add up the mass, multiply by today's price, and report a number large enough to justify the cost. What they will need to account for before a single launch contract is signed is the question that arithmetic cannot answer by itself: whether the price used in the calculation will still exist by the time the cargo arrives. That number is not fixed. It is the first casualty of a successful mission.